In this video, we're going to talk about the absolute value function. Now, I'm kind of assuming that you've seen the absolute value before, but the absolute value of x can be defined like this. Okay, the absolute value of x is equal to x if x is greater than or equal to 0, and negative x if x is less than 0. And that might seem kind of strange because how could the absolute value of x equal negative x? I thought absolute value was always positive. Well, let's look at a couple examples. The absolute value of 3, of course, is going to be 3. But how do we know that based on this definition? Well, we look at the input, 3, and we ask, is it greater than 0 or less than 0? Okay, it's greater than 0, so what we end up with is just x. And if we plug in 3 in for x, we get 3. Okay, now what about the absolute value of negative 5? Isn't it supposed to be 5? Okay, well, let's look at the formula here. Which one will we use, the top one or the bottom one? Well, negative 5 is less than 0, so we're going to use the bottom formula. So this says the answer is going to be negative x. But what is x? It's negative 5. So actually, it's negative 5. But what is negative 5? It's positive 5. Okay, so even though it might seem like a little strange definition, this really is the definition of the absolute value of x. And notice that it's a piecewise linear function. The graph will actually come in two pieces. We'll have one piece if x is greater than 0 and another piece if x is less than 0. And these are both linear functions. This is really 1x plus 0, and this one is negative 1x plus 0. Okay, so let's sketch the graph of the absolute value of x. Now, one way to do it would be to make a t-chart, right? A table of values. You can make x and the absolute value of x and plug in various values. So if you plug in minus 3, you get 3, minus 2, you get 2, and so on. Plug in positive numbers like positive 2, you get 2. Okay, and you can keep going. And notice these would give you ordered pairs, minus 3 comma 3, which would be about right here. Okay, these tick marks are, I'm assuming that they're all 1 apart here. Minus 3 comma 3, minus 2 comma 2 is right here. Minus 1 is here. 0 0 1 1 2 2 3 3 4 4 and so on. And it turns out what you get is a nice sharp corner. And there I've drawn it. Notice it's not rounded off at the bottom. It's like a parabola would be. It's a sharp corner right here. It looks kind of like a V. And in fact, you can see this really is a piecewise linear function. If x is greater than 0 or if x is less than 0, that tells us that our cutoff line will be 0. So basically the x-axis, or I'm sorry, the y-axis, where x is equal to 0. Now if we're to the right of 0, if we're to the right of the y-axis, our graph is going to look like x. And notice this is what y equals x looks like, right? F of x equals x looks like this. It goes to the origin, it has a slope of 1. Okay, 1x plus 0. If we're to the left of the x-axis, the graph is going to look like minus x, and this is what minus x looks like. Okay, it goes through the origin, it has a slope of negative 1. But again, we only consider minus x if we're to the left of the y-axis. Okay, we erase that part to the right of the y-axis. So this is what the graph of the absolute value function looks like.